Hi, everybody. Wow, I'm super excited to be here. And that video, I've always wanted to do that video, and we got it. So that's great. So, having my slides. So those are not my slides. No. Okay. So I hope the clock is not ticking for me, because those are not my slides. So meanwhile, this is Matternet ONE, the world's first drone exclusively designed and built for transportation. We launched this in March of this year. So this is something that, as we talk, is happening. This is not the future. This is actually today. And after you vote for me, I'll let you touch it and carry it. But it's very lightweight. And I'll tell you more while I'm talking, but basically, just so you see, this really works. It has a battery. There's just one way to put it. Oh, those are my slides. OK, so I'll tell you more later. But it's a really cool product, and I think all of you should have the chance to touch it and see how real it is. So I'm Paula. These are not my slides, neither. You should have the last one I gave you.
So let's do this.
Yeah.
Talk amongst yourselves and give us 5 minutes. Let's get it fixed.
OK.
And let me just explain something. The original speaker, her co-founder partner, was supposed to be here, got very, very sick. And we heard yesterday that he was going to be unable to come at all. And so Paula flew in and just got here this afternoon. So that's why a little confusion. It's not her fault. She's doing great. Just give us 5.
OK. So you've been very patient, so I'm going to cut to the chase. I'm Paula Santana. I'm co-founder and head of networks of Matternet. My co-founder, Andreas, is an amazing, genius guy. He's a little bit sick. He couldn't make it. But I'm going to try to do my best and tell you what we're doing together in Menlo Park in Silicon Valley. So 1 billion people today have no access to all-season roads. They can put their goods to market. They cannot get access to those goods. They cannot get medicines, vaccines. They are actually totally disconnected from any social and economic activity. That means that they cannot create a sustainable path out of poverty. So they're going to be in the cycle of poverty for a couple of decades. But so don't you think this is a problem of the developing world only. You need to remember that probably you and I are part of the 4 billion people that today live in very congested cities and megacities. So as you've heard throughout the day, we're spending over $100 billion in wasted fuel and lost productivity. And of course, we are leaving a huge ecological impact in our planet. So back in 2011, in Singularity University at NASA in Silicon Valley, we thought, is there a way to make this work for all of us? Can we do better? Could we leapfrog road infrastructure and provide a 21st century solution, not only for a few people, not only for the developed world, but for all of us? And back in 2011, we thought very hard, and we finally, because we thought we could and we were in Silicon Valley, we started to build that system. So that system comprises 3 key technologies. Number 1, small flying vehicles. Number 2, smart software. And number 3, landing stations. These 3 technologies are seamlessly integrated into what we call an ultra-flexible logistics and distribution network that works 24/7 in the background, like an internet, but for physical goods. And we call that Matternet, an internet of matter. For you, all you have to do is the following. You take your goods, you put it inside this vehicle, you close the lid on that little red box. You put the red box inside the vehicle, then you put the battery. So yes, they're electric. We're going for it. And then you turn on the propellers, and you see the vehicle taking off completely autonomously from one of the landing stations. The vehicle will send notifications to both the party that is dispatching the vehicle and the party that is receiving the vehicle. And when the vehicle is about to land and has already landed, you will be able to go and retrieve your package. So that's the technology that we are building. That's very easy for you to use, but what we are doing actually is creating everything that goes behind. So you can have access to a complete end-to-end customer solution that is a 21st century transportation system. It consists on the whole vehicle, the hardware that you see here, the software that lives in the cloud, the app, and the landing stations. And everything is seamlessly integrated, so you don't need to have any skills to operate this system. We don't want to overcome a challenge of lack of roads or of traffic, bringing a technology barrier so nobody can operate this. So this is why we made it very simple to use. Let's go in detail into the technology. Number one, it's Matternet ONE that I already told you about. It can carry 1 kilogram, 2.2 pounds, over 20 kilometers, 12 miles, completely autonomously. No pilot in command, no remote control of this drone. It has been exclusively designed and built for transportation. It is super lightweight. I invite you to touch it and carry it. And it uses GPS and sensors to know where it is and know where it's going. It also has a small parachute here that deploys in case of any hardware malfunction. The second components are the landing stations. They provide predictable, known locations where the drone is taking off and landing consistently. So you know at any given time that wherever there is that landing pad, there will be a drone taking off or landing. Our software that lives in the cloud is basically the smart part of the system. It's creating these virtual digital routes connecting the landing stations that are on the ground in real time. So it's taking into account weather, it's taking into account sensitive areas, restricted airspace, so we know that we cannot fly around 5 miles of an airport. We don't want to fly over heavily trafficked roads. We don't want to fly over school. And basically, this software will create the best, safest, and most direct route connecting these landing stations. Lastly, the app. You open the app in your smartphone. You can see the vehicles that are available for you to use. Let's say you have a fleet of 1 or 2 or 3. You select from one of the locations that you want to send your package to, and then you can create a route. Then you can see there the orange line that is basically the software trying to create a route in real time connecting these 2 locations. You see that red circle that is a restricted area, so we should avoid that circle. And basically, those also red squares, those are zones where we cannot take off or land. And the software does this by itself. There's nothing you need to do. And you turn on the propellers, and then you see the vehicle taking off. This is the whole system. Basically, you give a high-level instruction through the app. The app sends that instruction to the cloud software. The software downloads the route in the vehicle, and then you see the vehicle doing its mission completely autonomously. So our focus for the last 4 years has been to do first and last mile delivery of items of less than 1 kilogram, especially in healthcare logistics. Why healthcare logistics? This is a new technology with very bad reputation, and we wanted to shift the focus from this is the technology to what are we doing with the technology. So when you take this technology to places in the world that have no other alternative, like the developing world, where there's no way to connect one place to the other, and where there is very low regulatory barrier, but a lot of organizations that really need this, then you can see how people start operating the system and what is the impact that this can have in someone's daily lives. For example, we went to Bhutan, where we work with the World Health Organization, the Prime Minister of Bhutan, and the Ministry of Health. And we really went to Bhutan. It's a Himalayan country, very rough weather, almost no roads. But basically, we wanted to push the technology to prove that if this could work in the most remote places in the world, it could work anywhere. So we went there to do a feasibility study and basically connect rural clinics with hospital labs to enable 24/7 delivery of diagnostics, analyze the diagnostics, and come back with the medicine. We started that feasibility study in 2014, and basically we were able to transport something from a hospital to a rural clinic. It was received by a health staff that had no computer literacy, but she was able to receive the package just because the technology and the user interface was super simple. At the same time, in 2014, we worked with Doctors Without Borders in Papua New Guinea. Papua New Guinea has a big tuberculosis epidemic. The government requested Doctors Without Borders, that is a Nobel Prize organization, to come and help. And they called us because they cannot reach the people that live in the highland. So we went there and basically took those sputum cups that were in one clinic and took them all over to the location in the hospital where they could be analyzed. This takes Doctors Without Borders staff 4 hours every day. They need to go in a dangerous road for 4 hours to collect those sputum cups and then bring them and analyze them. And it took us only 55 minutes to do the same. So compare that. 4 hours of having your best staff in a dangerous road, in the best vehicle that is available, that in that case was a Land Cruiser, compared to 55 minutes in a drone that is completely autonomous, that is flying and overpassing all that jungle. And that is the power of an amazing technology being used today as we talk. The samples were received by the health staff and then analyzed in the lab. So that has been our work in the developing world. But in the developed world, we see a lot of applications and a lot of potential as well. So 75% of the packages that are shipped today by courier weigh less than 1 kilogram. Imagine removing 75% of everything that we ship today from our roads. Small package delivery is the fastest growing segment of logistics. So imagine that efficient last mile and on-demand shipping are the core of the next wave of e-commerce. So suddenly we could have a solution for this e-commerce boom that is happening. This is why we partner with Swiss Post and Swiss World Cargo. We went to Switzerland in July and we started testing this technology, but not in the developing world, in the developed world. We got the first permit issued by the Swiss Federal Aviation Authority for a fully autonomous vehicle to operate in their country. This is one of the vehicles that were in the fleet that went to Switzerland. For us, this was a landmark project, and it's very meaningful because it means that this is not something of the future. This is something that we envisioned 4 years ago and that we are making it happen. This is one of the videos that we could take of our vehicles flying in Switzerland. As you can hear, they are minimally invasive, so you only hear this buzz in the first 5 seconds while they are taking off or landing. When they are flying at 400 feet, you can't see them, you can't hear them. So this is the kind of thing we think can live in our cities together with us without, overwhelming us. And because this is a technology that we think will have a huge impact, we are working with our partners to make sure that the economics make sense. So we are working in a format that is a leasing model of $2,000 per drone per month. And if we do the breakdown, you can see that assuming a cost per month of $2,000, the cost per day, assuming that our partners operate 7 days a week, comes down to $66 per day. The average distance, let's say that they're going to be traversing is going to be 5 kilometers, and that will allow them to do between 3 to 4 deliveries per hour. And assuming that they operate 14 hours every day, they will be able to do 43 deliveries per day with this technology, meaning that every delivery will cost only $1.50. If you scale the numbers, delivering something over 10 kilometers will cost only $2.50, and over 20 kilometers, barely $4.60. So you see how this plays in today's life. We are based in Menlo Park. We have Whole Foods 2.5 kilometers away. And if we order something from Whole Foods today, we can get it from any on-demand app. We use a lot Postmates. It will take 40 minutes from something to come from Whole Foods to Matternet, and it will cost $11 only the delivery. But via Matternet, you can get the same good in 10 minutes, and it would only cost $1.50. So this is 1/10 of the cost of what we're paying today for transportation. So we are doing something huge. We are creating the first fully autonomous transport networks in the world. Imagine that any transportation or logistics company today, they have fleets of vehicles, aircrafts, motorcycles, bikes, trucks, and none of those vehicles are fully autonomous. So I'm telling you that the first vehicles that will be autonomous in your fleet are a vehicle that you have never used, you have never operated, and you didn't see that coming. And it's available for you today. We've received over 700 requests of this product that in some parts of the world, in most parts of the world, is today illegal. This is innovation eating the world and eating any regulation. We've been, talking about this, what we're doing for a while. We've received a couple of amazing awards by Verizon, being recognized as one of the transportation innovations last year, more recently by the World Economic Forum as one of the technology pioneers of 2015. And our team, it's not only outstanding and brilliant, it's also a team that has been to the field. We wanted to be there and see how this technology could impact the life and change the life of these people. We've been to the developing world, we've been to the developed world, we have software engineers from Stanford, industrial designers from the Royal College of Art, Georgetown law students from Georgetown and George Washington trying to work with FAA and the White House and Congress to create this framework for the new regulation that needs to happen in the world. And the question we ask ourselves, what is in our imagination is, what are we going to put in these red boxes? Either medicine, diagnostics, or important documentation, or small goods. What are we going to put in these red boxes that will create the next transport networks in the world and will connect people and will give them access to the goods they need when they need them? We are creating 5 networks next year. We hope that if we get this prize, this will fund one of those networks, especially in the developing world, where many people pay between 50 and 100% more just in logistics and distribution. Or also in the developed world, where we can have more livable cities that are, more green, more easy to have in our daily lives. And finally, working with the organizations, the companies, and the institutions that want to provide people access to move things, to give them, to reach them out, and to really make an impact and change the way they live every day. Thank you very much.
Brad.
An idea of the cost of the energy equation in terms of kilowatt hours per kilogram per kilometer, and then how much flexibility do you have in that pricing overall based on the cost of the system? And then do you have any built-in sensors for avoidance?
Great question. So the first question, it's very difficult for me to explain it in how the formula works, but I can explain it to you in lay terms. So because you have a very small vehicle that is carrying almost its own weight, the energy that it consumes to move something 20 kilometers away is much more less than if you have a vehicle that weighs 200 pounds and then have 200 other pounds of a driver to just move 1 kilogram. We think that it will, that the energy cost will be 4 cents of a dollar to move something over 10 kilometers. I can share with you the formula in more detail, but this was one of the breakthroughs where we saw, wow, we're moving something very small, and depending on the country we are and how we are obtaining that energy to put in the battery, that will affect the formula, but we think the consumption of energy is going to be so much low compared to any other vehicle that we're using today. Regarding C-Sense and Avoid, we are trying to take a different approach. C-Sense and Avoid are, these sensors that you can put on a vehicle, so when the vehicle is flying, it can see its environment, sense its environment, and then try to avoid an obstacle. What we're doing is trying to do the most C-Sense and Avoid that we can before we even take off. So we have very accurate maps on the highest obstacles. That's number one. So fixed obstacles are not a problem because we already know that they're there, and the software is making a route that avoids these obstacles. Then you come with the problem of other vehicles or helicopters or unforeseeable objects like birds. So for other vehicles, we know that C-Sense and Avoid technology is coming. It's being highly commoditized. We just need to integrate it into our platform today. It's not a today problem because there is nothing else below 400 feet where we want to fly there. Institutions like NASA are working on creating these air traffic management systems at low altitude where before I take off, I need to send NASA my flight plan, and then NASA will take that flight plan and take other vehicles' flight plans and deconflict the airspace even before I take off. For the third type of problems that are birds, we make this joke that, well, birds have C-Sense and Avoid. They should see me and move out of the way. But we know that this technology is something that C-Sense and Avoid will definitely be in every vehicle as we move on and start congesting the airspace. So it's something that is out there. We just need to integrate it into our platforms.
Anyone else? Yes.
I have several questions, if that's all right. First one is, does it work in the rain? And if it doesn't work that well in a rainstorm, is there insurance that you have to consider?
Yes. So yes to both. It works under moderate rain. This was one of the things we wanted to try out in Papua New Guinea and in Bhutan because, of course, you have a great vehicle, but if it doesn't work when they're in the rainy season, what are we bringing? So the technology, has limitations and capabilities. Today, we can fly under moderate rain, under winds of up to 8 meters per second, but we're pushing the technology so it does more than that. It has full insurance coverage. This special vehicle has insurance for up to $1 million anywhere in the world. We got one of the first policy programs for this type of operations, and it's fully warranted by us. So, if something wrong happens, there's insurance there, but you can also send the vehicle back and we'll send you a new one.
Great. My second question is security from hackers or would-be thieves during retrieval of the goods and or while it's in flight.
So the reason why this is a system is because every user that has the app in every vehicle is linked to its user. So we know at any given time who dispatched a vehicle, who received the vehicle, who you send this vehicle to, which landing station it was dispatched from, and which landing station it was received. One of the reasons we're working with organizations and businesses now only is because we can have more control of the system. We can know that the person who is dispatching or receiving a drone are part of a company that has been trained or has an incentive to protect the technology. So every location where it takes off or land is protected as well.
So for hackers, do you have some security software?
So all the information that is being shared, like through the cloud, the instructions, is encrypted. We know that there will be, like with any technology, attempts to hack the system. We have not experienced any yet, but when that happens, we will need to see how to react to that because, people can do that.
I have several more questions, but I'm just going to ask one of them in the interest of time, and that's how do you screen clients like drug cartels?
So that's a great question. We have received over 700 requests. We're only working with very select clients because we want to make sure that we're highlighting the technology and the impact it can have. So today we have only 5 clients. Next year we will have more, but we're focused on creating these networks. And of course, we need to make sure that we understand who the client is, what is their purpose, and we are the ones setting up those networks. So we know where everything is going to be moved to and from, and what is the intent. Of course, as the technology becomes mainstream, we will need to integrate other measures to, fight against that.
Thank you very much. I appreciate it.
So let me ask a question. Talk to us a little bit about your go-to-market strategy and your business model going forward.
So as I mentioned, our business model is basically leasing these for $2,000 per drone per month. So our customers can grow their networks as they see fit. They can add nodes. They can remove nodes from one location and take the drones to another location. And it includes all the hardware, all the software, all the warranty, and all the insurance. So you pay $2,000, and I make sure that you have a drone flying 24/7 in the skies.
Okay, so that's plan is all.
Yeah, and we're working now with healthcare logistics companies, so from hospital labs to NGOs focus on healthcare, pharmacies, diagnostics companies, to companies that do the logistics for them, transportation companies that just focus on that as well.
Right.
So that's what we're doing now.
Then would you talk a little bit about, if you were to win one of the prizes, what you would do with the prize?
So we, as I mentioned in my talk, we would fund one of these networks that we're creating in 2016. We did these feasibility studies in Bhutan and in Papua New Guinea in 2014. Those were the first step towards creating these permanent networks. We are also having projects in Dominican Republic. The same is working with the ministries of health, trying to provide the transportation muscle that can actually connect all this infrastructure that they have on the ground. So it would be about connecting the rural clinics or clinics that are dispersed with the hospitals and allow this 24/7 exchange of critical goods, medical supplies, first aid, diagnostics, vaccines, and whatnot.
Okay,
so
great.
we would allocate those funds towards creating those networks and operating them.
Okay, great. We have a question here.
One quick question on the connectivity. If I'm assuming correct, it uses the GSM data networks to download the data onto the onboard processor.
That's correct.
So coming to the main question, Internet plus Matter, in developing countries, if you're trying to use this, especially in the mountainous areas, the GSM network is pretty bad. And the second alternative will be to use a normal digital communication via radio waves. Again, I know there are a lot of red tapes regarding the airwave regulation even there. So how do you plan to address this challenge?
So we wanted to test exactly that. Especially also in Switzerland when we went, we were required by the aviation authorities to have a lot of redundancy to make sure that if we lose GPS, if we lose some cellular connectivity, we have some other alternatives for positioning systems and cellular connectivity as well. In Bhutan and in Papua New Guinea, surprisingly, we didn't have these challenges. So you can have less signal, but we never lost completely the signal in the places where we were taking off or landing. We also architected the system understanding that we might lose cellular connectivity in the way. So the system only requires cellular connectivity when you are sending it an instruction in the takeoff or landing location. So if you have cellular connectivity during the whole travel, you will know in real time, you can monitor the vehicle and you will know where it is. But it doesn't need cellular connectivity because it already has the route downloaded in the vehicle. So it can lose the connectivity and it will continue its own path until it arrives to its end destination.
Over here?
Go to Mr. Williams first and then come back.
You were first? Okay, let's go over here.
Padla, you recognized earlier that I was with the FAA. Should I explain that or no? Oh, okay. No, she said my name, Jim Williams, was the same as the head of drone control, FAA. So I'm not, of course. My question for you, though, is what distance can you grow to that you can cover And also, what's the weight maximization that you can carry now, and will you expand that as well?
Yes, so we've seen that we could do a lot by just remaining small. Almost 86% of everything we buy in our daily lives is less than 2 kilograms. So we know that we can go to 2 kilograms and do 86% of everything that we buy. Of course, staying small has a huge plus. It's minimally invasive. The noise it produces is very small. The bigger we go, the more challenges we have, especially, if this falls from the sky, the chances that it hits someone because it's so small, they get constrained. The bigger we go, the more challenges we have. On the distance and the weight as well, it's a battery question, right? So we can go longer distances and carry less weight with what we have today, or we can go longer distances and carry less weight. We think that we can, and we are working with other battery chemistries to be able to expand the distances that we can go, but we think that with 20 kilometers that we have today is enough to capture the first and last mile. Also, it's important to notice, and this is something that we checked while we were on the field, that usually companies and organizations already have a physical network on the ground. It's just about connecting them. So for example, in Bhutan, there are clinics that are 80 kilometers away from a hospital, but they're 20 kilometers away from the closest other clinic. So we can do from hospital to a clinic that is 20 kilometers away, from that clinic to the next clinic that is 20 kilometers away. And this is the network effect. You can go from one place to another, make a stop, change a battery manually, and then the system can go on and on until it reaches its final destination.
Okay. Last question over here.
So I have two. One is, you're interested in delivery, I'm interested in surveillance. So have you thought about the possibility of using your drones for surveillance purposes? There's some sanitary reasons that surveillance is a good idea, like if people are cutting down rainforests and a government wants to know where they are and what they're doing, this could be a cheap method of following up and monitoring rather than the non-existent methods that are used now. So that's one question. And the second question has to do with competition within the industry. So other companies make drones. What's your competitive advantage?
Thank you. So our bet was to create the world's first autonomous transport networks. We've been doing that for 4 years. Being in Silicon Valley has been very challenging because many of people in our circle is pushing us to do other type of applications. But we understand that the only thing we care about really is transportation, so we've stick to that vertical, and we've understood it better than anybody else, and this is why we have the only vehicle for transportation that you can have today. So, there's a value in focus and also a value in mission. That's what we think. Transportation is what we think will create the most value for the use of drones in the next couple of years. So that's the only thing we're doing. As long as competition concerns, we know that there are other players, and for us it's great to know this, like out of probably the 5 most important technology companies in the world, 2 that are using drones, they want to use drones for transportation. So when this was a crazy idea back in 2011, then suddenly these companies come in and you validate a market and then you get funding, which is great. It's still very early to say who's going to be doing what. So you've heard about the Amazon drones. It's unclear if they want to provide their own services, if they want to have their own drones, but what we do know is that if Amazon comes in and they want to have their own drones to deliver things for the people that sell stuff and buy stuff in their platform, then you have 400,000 other clients like FedEx, UPS, DHL, that they won't build their own vehicles probably because they don't build their own trucks. They buy them from Mercedes. So what we are betting is that we can become the best company building small drones for transportation, and that's our only focus, and that we can sell this technology from companies like DHL, FedEx, UPS, to Amazon, if they decide to buy from us, to any NGO and probably to any individual as well that wants to set up their own transport networks.
Okay, time's up. Great job. Thank you very much.
Thank you.
Paula Santana, great job.